Our planet's oceans just absorbed the energy equivalent of 12 atomic bombs, every single second, all of last year. That is not a prediction. That is not a worst-case scenario from a climate model. That is the measured, documented reality of the heat our planet is now accumulating. In 2025 alone, the Earth's oceans took on 23 Zetta Joules of excess energy, a number so large it's almost meaningless. 23 followed by 21 zeros. A heat spike that one of the scientists who measured it, Professor John Abraham, called alarmingly large. The ocean is the planet's great buffer, the silent engine absorbing over 90% of the heat we produce. And that engine is now running hotter than at any point in human history. Let us know in the comments if you've noticed stranger, more extreme weather where you live. Your observations from the ground are a critical part of this story. Here is the part nobody is talking about. Most people who watch our videos, who get this critical information, forget to subscribe. It is a small click on a screen. But for an independent channel like this one, it is the only way to get this reporting past the algorithm and in front of more people. This isn't just content. It is an emergency broadcast. Please, take 1 second and hit the subscribe button now so you don't miss what's coming next. Let's begin. The Pacific Ocean is the largest body of water on Earth, so vast it could hold all the world's continents with room to spare. And what happens in this ocean does not stay in this ocean. It governs the weather for billions of people. It dictates where rain falls and where it doesn't. It decides if a winter is mild or brutal. And right now, the Pacific is running a fever. On September 9th, 2025, the average surface temperature of the Northeast Pacific Ocean hit 20.6 degrees Celsius, almost 69 degrees Fahrenheit. That is not a local reading in a shallow bay. That is the average temperature across a massive expanse of the Northern Ocean. It was a record, the highest ever measured, a signal that something fundamental has shifted. This is the part that should stop you cold. That moment was not the start of the problem. It was the confirmation of a process that has been accelerating for years, hidden just beneath the surface. To understand what that number means for your life, for the weather you will experience in the coming years, you have to look past the surface. You have to look at the heat the ocean has already swallowed. For decades, the single best indicator that our planet is warming has not been the air temperature. Air is fickle. It fluctuates wildly day to day, season to season. The real story, the undeniable proof, is in the water. Kevin E. Trenberth, a distinguished scholar at the National Center for Atmospheric Research, has made this his life's work. He argues that global ocean heat content, or OHC, is the most robust metric we have. It's the planet's true thermometer. And that thermometer just shattered its own record for the 9th consecutive year. The landmark study, published on January 9, 2026, in the journal Advances in Atmospheric Sciences, compiled data from an international team of researchers. Led by Professor Li-Jing Cheng from the Chinese Academy of Sciences, they confirmed what many had suspected. The 23 zettajoules of heat the oceans absorbed in 2025 was an unbroken historic high. Here is the number you need to hold in your head: 23 zettajoules. To put that in terms you can picture, it's enough energy to power the entire global human civilization, at its current rate, for 37 years. All of our cars, all of our factories, all of our cities, all of our lights. 37 years of energy. That is the amount of extra heat the ocean absorbed in just 1 year, 12 months. That heat does not just disappear. It does not get stored harmlessly in the deep. It becomes fuel. It changes the physics of the ocean itself, and it is building towards something. The first warnings were not graphs on a chart. They were dead birds, millions of them. Between 2013 and 2016, a monstrous patch of unnaturally warm water appeared in the North Pacific. Scientists nicknamed it the blob. This was not an El Niño event, the semi-regular warming of the equatorial Pacific that people are familiar with. This was different. A rogue system, a vast expanse of ocean where temperatures sat several degrees above normal for years. It was caused by a stubborn high-pressure ridge in the atmosphere that blocked the winds. Without wind to churn and cool the surface, the ocean's upper layer just sat there and baked under the sun. The consequences were catastrophic. Heather Renner is a supervisory wildlife biologist with the U.S. Fish and Wildlife Service. She co-authored a study that put a number to the devastation: 4 million. That is the updated estimate of how many common murres, a resilient black and white seabird, starved to death during the blob. some 62,000 of their emaciated carcasses, physically washed ashore on beaches from Alaska to California, a gruesome clue that something was terribly wrong in the offshore ecosystem. Renner's words cut through the clinical language of science. "I think what really punched us in the gut," she said, "was having a really abundant, widespread top predator that, over a really short period of about a year, lost half of its population." Half. Gone. The birds did not die from a disease. They did not die from a chemical spill. They starved. And to understand how, you have to understand one of the most cruel paradoxes of a warming ocean. Scientists call it the ectothermic vice. It works like this. Murrays, like Pacific cod and other cold-blooded marine predators, have metabolisms tied directly to water temperature. When the water gets warmer, their metabolism skyrockets. They get hungrier. They need to eat more food, more often, just to survive. But the very same marine heat wave that is making them hungrier is simultaneously demolishing their food supply. The warm water cap, the blob, blocked the upwelling of cold, nutrient-rich water from the deep. That cold water is the foundation of the entire marine food web. It feeds the plankton. The plankton feeds the krill and small bait fish. The bait fish feed the bigger fish, the seabirds, and the marine mammals. When the upwelling stops, the food chain collapses from the bottom up. Plankton disappears. Then the bait fish vanish. So the murres and the cod found themselves trapped in a metabolic vice. Their bodies were screaming for more food at the exact moment the ocean's cupboards went bare. They burned through their fat reserves and then their muscle tissue. And then they died. By the millions. The scale of this ecological collapse is hard to grasp. What part of this story hits you the hardest? The millions of dead birds? The starving fish caught in a metabolic trap? Let us know in the comment section below. We read them all. And the birds were not the only ones in crisis. The heat forced a mass exodus. Entire populations of marine life began a desperate migration to find cooler water. Scientists found that to stay within their preferred temperature range, some species had to travel up to 1,000 miles from their normal habitats. Subtropical loggerhead turtles and swordfish, normally found in warmer southern waters, began showing up in the Southern California Bight, far north of their usual grounds. The ecosystem was not just dying, it was being rearranged, violently and on a continental scale. The blob eventually dissipated in 2016, but it was a dress rehearsal. It showed what a persistent marine heat wave was capable of. And now, they are returning. Except this time, they are bigger, more frequent, and not always tied to a clear cause like a blocking ridge. The baseline has shifted. The ocean is just hotter. The 2025/2026 marine heat wave currently gripping the U.S. West Coast is, according to NOAA, the third longest massive heat wave on record that is not directly linked to an El Niño. It is a product of the new normal. Andrew Leasing, a research oceanographer at NOAA, manages the California Current Marine Heat Wave Tracker. It's a real-time dashboard for a slow-motion catastrophe. The maps his team produces show vast regions of the Pacific locked in a permanent state of moderate to severe heat stress, month after month. This is not a cycle anymore. It is a new state of being. What makes this more than just a tragedy for fish and seabirds is how the ocean's physics are changing. A warmer ocean is a more stratified ocean, and that is the part that connects this entire crisis back to of all of us on land. It's simple physics. As the surface water of the ocean absorbs all this heat, it becomes lighter, more buoyant, than the cold, dense water in the deep. This creates what scientists like Michael McFadden at NOAA's Pacific Marine Environmental Laboratory call a cap. The warm surface layer effectively seals off the deep ocean, like a lid on a pot of boiling water. This stratification has two profound consequences. The first, as we saw with the murres, is that it stops the upwelling of nutrients. The biological pump that feeds the ocean turns off. The second is that it traps even more heat right at the surface, where it can interact with the atmosphere. The ocean's ability to mix and bury that heat in the deep is weakening. Ngata's warming, or weakening the surface, McFadden's research shows that human-caused warming is actively shrinking the surface mixed layer, trapping heat in a thinner and thinner band at the top of the ocean. A stratified ocean is a less productive ocean. It is also an ocean that is primed to wreak havoc on global weather patterns. The heat isn't staying put. It is being weaponized. It fuels the atmospheric engines that deliver our weather, turning normal cycles into extreme events. Think of the warmer Pacific as a massive battery, overcharged and unstable. That stored energy has to go somewhere, and increasingly, it's being released in the form of supercharged storms and amplified droughts. The most powerful example of this is the El Niño Southern Oscillation, or ENSO. This is the planet's most influential natural climate cycle. It is driven by the Walker Circulation, a massive loop of air that flows east to west across the equatorial Pacific. Normally, this circulation pushes warm surface water toward Asia, keeping the eastern Pacific, near South America, relatively cool. But every few years, the Walker circulation breaks down. The winds weaken or even reverse. That vast pool of warm water, no longer held back, sloshes eastward across the Pacific Basin. This is El Niño, and where the warm water goes, the storms follow. The entire global atmospheric pattern reorganizes around this new hotspot. The jet stream gets pulled south. Storm tracks shift. Places that are normally dry get floods, and places that are normally wet get drought. Now, inject 23 zettajoules of extra heat into that system. In June of 2026, NOAA forecasters made it official. A new El Niño has developed in the tropical Pacific. That is not unusual in itself. What is unusual is its potential intensity. Forecasters have put the odds at 63% that ocean temperature anomalies will exceed a blistering plus 2.0 degrees Celsius by the fall. That is the threshold for a very strong event. An El Niño on steroids, supercharged by the background warming of the entire Pacific Basin. The implications are immediate and global. This winter, the southern United States is staring down the barrel of a wetter, stormier season. The northern US and Canada are projected to be warmer and drier, but these are just generalizations. The reality on the ground is far more violent. Consider what happened in the winter of 2022 and 2023. California was hit by 9 consecutive atmospheric rivers over a 3-week span. 9. An unprecedented cluster of storms that slammed the state one after another, with no time to recover in between. Atmospheric rivers are literal rivers of water vapor flowing in the sky. When they make landfall, they can dump biblical amounts of rain and snow. Researchers at the Center for Western Weather and Water Extremes, or CW3E, have linked the intensity and clustering of these events directly to ocean-atmosphere interactions over the hot Pacific. The anomalously warm zones act like a slingshot, gathering moisture and then launching these focused streams of vapor directly at the west coast. The ocean's heat becomes the fuel for land-based flooding. If you know anyone who lives in a place affected by these extremes, brutal floods, endless droughts, please like this video and share it with them. This information might help explain the world they are living through right now. I know we've mentioned it before, but it means you understand just how critical this story is. We are a small, independent team, and every single subscriber is a lifeline. It allows us to continue this work. If you haven't yet, please take one moment. It makes a world of difference. While the atmospheric rivers are drowning one part of the country, the same ocean dynamics are desiccating another. The same warm Pacific water that fuels storms can also lock in patterns of drought. This was felt acutely on the Sacramento River in California. The river is home to the highly endangered winter-run Chinook salmon. During the 2013-2016 marine heat wave, the associated drought patterns became so severe and the river water so warm that an entire generation of salmon was wiped out. 95% of the eggs laid in those years were lost, cooked in warming water before they could even hatch. The population has never recovered. This is the two-faced nature of the crisis. Too much water in one place, not enough in another, with the Pacific Ocean acting as the master switch. A hotter ocean creates a more volatile world. The problem is, our entire society was built on the assumption of a stable climate, of predictable cycles. Our dams, our farms, our cities, all were engineered for a world that no longer exists, a world with a cooler, more forgiving ocean. The evidence now suggests we are moving past the point of cycles and into a new, permanent state. The fact that the Pacific is spawning massive marine heat waves outside of El Niño years is perhaps the most damning piece of evidence. It shows that the background state of the system has changed. The ocean is now so full of heat that it can generate these monster blobs on its own, without the push from a natural cycle. This is a fundamental shift in the planetary machine. We have overloaded the primary thermal buffer, 90.1%. That is the percentage of the entire global ocean area that experienced at least one marine heat wave in 2025. It is no longer a regional problem in the Pacific. It is a global condition. The ocean has been our silent protector, absorbing the consequences of our industrial age quietly, invisibly. For a century, it took the heat. It buffered the change. It bought us time we did not know we were being given. But that service came at a cost, a debt of energy that is now coming due. The heat we pumped into the ocean is not gone. It is just waiting. It is in the stratified surface layers, fueling stronger hurricanes. It is in the amplified El Niño cycles, redrawing maps of rainfall and drought. It is in the silence of the North Pacific, where millions of seabirds once flew. We can see the data, the 23 Zetta Joules, the record temperatures, the 9 consecutive years of warming. The scientists who measure this, like John Abraham, have run out of calm words. "Holy shit, the oceans are hot," he said, reflecting on the 2025 numbers. It's an exceptionally large increase, and it's surprisingly large, and it's alarmingly large. The world's top experts are no longer speaking in cautious academic tones. They are using the language of emergency. The agencies issue the warnings. NOAA announces another record warm month. The WMO confirms another record warm year. The science is published in journals, reviewed, and confirmed. The data is unambiguous. The trend lines all point in the same direction, up. And yet, it remains a crisis that feels distant, happening somewhere out in the middle of the ocean. But the flood that washes away a road, the drought that withers a crop, the wildfire that burns through a forest parched by years of missing rain, that is the ocean, speaking to us in a language we can no longer ignore. The heat is not staying out there. It's coming ashore. It's in the price of food after a harvest fails. It's in the cost of insurance in a flood zone. It's in the smoke-filled skies of summer. We treated the Pacific like an infinite heat sink, a planetary utility, a convenient, out-of-sight place to dump the thermal waste of our civilization. The scientists, the data, the dead birds, the empty rivers, they are all telling us the same thing. The buffer is full. The shock absorber is broken. One last time, and I promise this is it. If this story clarified the world for you in any way, subscribing is the single best way to ensure we can make the next one. Thank you for watching. The system is now running on its own momentum, powered by the heat it has already accumulated. The question we never seriously asked ourselves is now the only one that matters. We always knew what would happen if the planet got warmer, but what happens when the very ocean that was protecting us becomes the engine of the crisis itself?